Today is lesson 4, and obviously a little bit of a late start. I had some connectivity problems which seem to have resolved themselves, fortunately. So today we're going to focus on working with our database. We're going to do a lot of the heavy lifting in our project today. So we're going to look at SQL Server. We've got a small graded activity, discussion activity here. We've already done this. We created our databases both locally and on Azure. We did that at the end of lesson 3. We're going to look at the DB context class that comes in ASP.NET. This is a database connection object. It's actually baked into our project already. So we're going to look at how that works. We're going to spend some time planning out the database we need for our store. Then we're going to use this tool called migration. So what migrations do is they inspect any model classes in our MVC project, and they migrate or they copy those classes into a database. So that structure gets mirrored automatically. It saves us time and it improves the accuracy. And then we're going to look at scaffolding tool. So a Visual Studio code generation component that will generate working controllers and views. So that should be pretty much all the tools you need to do assignment 2. If we have time, we'll also look at deploying our bookstore to the Azure portal. If we don't have time today, we will cover that in class next week. And just one note, I'll also remind you about next week's class. Next week is Thanksgiving. So we don't have a live class on Monday, so we will have an asynchronous class. So I will record the lesson. I'm trying to think, probably next Tuesday afternoon is the most likely time. So I will send out an email letting you know when the Tuesday lesson is online. Okay. Actually, you know what? I'm going to modify this item. Bear with me for just a second. I'm not sure whether we're going to make this graded or not. So hang on just a second. If we don't need to, if it won't mess around with all of our grades, then we'll make it an ungraded activity, but just bear with me. Okay, yeah, we do. Okay, so here's what I want you to do. I'm going to pause the recording in a minute. You may have seen this video before, I'm not sure. It's 9 minutes, and what I want you to do as you watch the video, I want you to note 3 reasons why you might want to use SQL Server when you're building an application. And then you can go to this discussion topic and post your answer here. Okay, so this is part of your in-class learning activity grade. And maybe when you come back, just give me a thumbs up in the WebEx room so I know that you are done. Okay, you don't have to submit into the forum now. You could make notes and submit later. If you're doing this lesson asynchronously, then you do have until next week to submit. But I'll give you some time to get this off your plate right now. So it's 9 minutes for the video. It shouldn't take you more than 5 minutes. So we'll come back probably around 1:25. People should be done. Okay, so it's the Why Use SQL Server item here in the lesson 4 folder. So I'll pause the video and let me know when you're done the activity. Resume our recording is cost. Now keep in mind, we are using SQL Server Developer. So if we go and look at some of the different versions, right, we're using the developer version, which is fully featured and it's free, but it's only used for development. It's not designed, it's not licensed for production use. And same with the Express version, which is an even smaller. In terms of cost, if we're looking at something like SQL Server Enterprise, here's the licensing cost. So it's not exactly low cost to run in a production environment. Okay, so you can see some of the pricing here. So it actually is in the industry level, it's not a cheap product. Something to keep in mind. We get it for free because we're students and we're not building production apps with it. But those who do, they're paying licensing fees that are often fairly significant. So how popular is it? Let's go here. So this was just updated. So this site ranks 380 database management systems, and SQL Server is and has been for years ranked as kind of number 3. So it's the smallest of the big 3, Oracle, MySQL, and then SQL Server. And it really dwarfs, notice the 4th place, PostgreSQL and MongoDB. They're quite a bit behind in this metric. Although certainly these databases are catching up. You can see the big 3 are all decreasing in popularity. So these numbers are getting closer and closer, but still Oracle, MySQL, and Microsoft SQL Server, these still really dominate the market. Sorry, Megan, is that compared to other database management systems? It's on the more expensive end, yes. So it would be priced similar to things like DB2 and Oracle. But considering that things like MySQL, PostgreSQL, MongoDB, that those are all open source, then yeah, that licensing cost for SQL Server is pretty significant. Fair question. Okay, so today we're going to work with the database. We've already sort of looked at what SQL Server offers. We set up a database in SQL Server last week. We did both a local version and an Azure version. So what we want to do today are these things. We want to configure our application to connect to a database. We want to generate database tables based on our Visual Studio models. Then we also want to scaffold controllers and views so that we can do CRUD within the application. So we've looked at these things. So I've put notes here. These slides are on D2L for you. So the step-by-step instructions for how to create a database locally. Again, you can also see this at the end of the lesson 3 video. And here was how to do it in the Azure portal. So before we can connect our project up to SQL Server, we need to plan out our database that we're going to need. So I've opened up the project, our bookstore that we've created. I got it running in Visual Studio. So here's where we left off a couple weeks ago. Sorry, last week we could add or list categories. But before we go through this process of connecting it, we should design the rest of our schema. So I'm going to close all the files up with the exception of our category model. Now I'm going to make 2 changes in the category model. Because this is going to be an auto-generated field, we typically don't include any annotations. I don't need to set a range or give it an alias because the users aren't going to be assigning the values anyway. It's going to be the database that assigns these values. So in your model folder, in this category.cs, let's take out those annotations. We don't typically need them on the primary key field. So we will keep this category model. I'm going to suggest we're going to need 4 more models in order to build this application to be like an e-commerce bookstore. So we're going to keep categories. What other models, what other classes, or what other database tables are we going to need in addition to categories? I know there's lots of different ones, but I'm thinking we need 4 primary tables. Okay, so we will have, yep, Megan, I agree, either a books or products table. Yep. Okay, books table. What else? What are the other tables going to be that we're going to need? I think we're going to need 3 more. Little categories, books. Yep, we're going to have orders. Chris, we are going to have users. We don't actually have to build the users table. That's actually going to come from the identity framework that we included in our project setup. So we are going to have a users table, but we won't need to design that one ourselves. And we'll see that a little more. We'll see that a little later in the lesson, and then particularly in a couple of weeks. Okay, so we've got products, books, orders. I think we need 2 more tables. One that's part of the process before we get to the orders, and one that's part of the process along with orders. Okay, Preston, you're close. I think we're thinking about the same thing. Adil, I will plug I've been on Wi-Fi. I plugged back in. I don't know. I'm on wired now. We'll see if that makes any difference to the internet connection. Adil said the stream is lagging.
I'm sorry, sir, for cutting like this, but your webcam is for me just cutting in and out, and your screen it's kind of like lagging for me. So I just wanted to confirm if it's just me or no. Like now I can see your mouse perfectly fine, but a bit earlier was just lagging a lot.
Okay.
All right, it's just me. I just wanted to confirm. All right, thank you.
All right. Okay, thanks, everyone, for chiming in and letting me know. Okay, so let's do this. Let's draw it out this way. Yeah, Preston, I'm thinking of a cart class. Yes, we'll want a cart class. Okay. So I'm just going to add a few tables here, and I'll save this and upload it. So we've already got categories. We'll need books. Chris, we're only going to, I think, if we could have multiple payment methods, for simplicity, I think we'll just have one. So we'll have carts. Whoops. We'll have orders. We're going to need one more table. Any thoughts of what that other table should be? So we will do payment, but we're only going to have one payment method. Megan, I think the prices can be in here. It's going to be related to the orders table. Well, it'll come out in a minute. Let's start to think about the relationships. What relationships do you see here between the tables that we have? So let's start with categories and books. What sort of relationship is there here? One category is related to how many books. One book is related to how many categories. We're just thinking of these 2 tables. Okay, Sam, we'll come back to that one. Hang on, you're one step ahead of me. Let's first look at this relationship. Let's think about categories and books. Yeah, okay, and in which direction, Chris? I agree, one to many. One book is in many categories. Adil thinks it's the other way around. Many books. Okay, one category. So we have to think of it from both sides. One category has how many books? One or many? A single category has how many books? Okay. Yes, Megan, we'll come to the other side in a minute. So Sam, thank you for answering my question, right? Many. One category can have one or more books. So we know this is going to be a one. What about from this side? One book can be in how many categories? One or many? And Megan, I think you're on the right track. There's two possible answers here. Okay, so Sam and Adil say many as well. So a book could be in many categories. That's true. I'm thinking for simplicity of our application, though, maybe we'll just make a book in a single category. You're not wrong. In a real bookstore, we might find a book that shows up in different categories. But for simplicity, maybe we'll just make it one category, many books. And actually, I'm going to call this table cart items instead of carts, cart items. What about the relationship here? One book can be in how many cart items? One or many? One book can be in how many cart items? So one book, well, Preston, can you and me and I both put the same book in our cart? Right. So if we can both put the same book into our cart, then one book can go in many carts, right? Because we can both buy the same product at the same time. So this is a one side, and this is going to be the many side. One cart item can hold one and only one book. So we're going to go one to many, one to many. So Sam, now we're going to come back to the relationship between books and orders. What's this relationship like? One book can appear in how many orders? One or many? How many orders can we have for one book? Yep, Megan, that's right. So one book, many orders. One order can have how many books? One or many? Also many, right? So here we've got a many-to-many relationship between books and orders. One book can be purchased many times, and one order can have many books. So what do we do here? How are we going to reconcile this relationship between books and orders? We can't quite do it with the existing table structure, can we? So how do we represent a many-to-many relationship in a normalized way? You know, you would have done this in your database class. Some of you are going to have to do it in your assignments. Preston, we do need a foreign key, but we need more than that. Because think about it, if one order can have many books, well, one foreign key isn't going to be sufficient, is it? Right, thanks, Chris. We're going to need an intermediate or a junction table that sits in between these two and reconciles the many-to-many relationship. Oops. So that table we'll call order details. So I make an order and I buy 3 books. I'm going to get one order record, and then I'm going to have 3 detail records here, each one listing the individual book that I've bought. So we'll flesh out all these relationships in just a minute, and I will post this. Okay, so we've already got here the category ID. I'll put in all my primary key fields. And I'm following the naming convention. Our table names are going to be plural, but the primary keys are singular and then ID. And now I can add my foreign keys. So I'll add the foreign key here. So every book belongs to a category. I've got a foreign key in cart items. So one book can be in many cart items. Put this table, whoops. This table actually gets 2 foreign keys. So it's got a book ID and it's got an order ID. So there are relationships. Now we need to flesh out what the rest of these models look like. We know that category has a name. That's about it. Okay, so we're going to do a little database design. Here's what we're going to do. This shouldn't take very long. I'm just going to create 4 random breakout rooms. And here's the assignment. If you're in breakout room 1, you're going to work together to design the book model. If you're in breakout room 2, you're going to do the cart item model. Room 3, the order model. Room 4, the order detail model. So I'm going to give you 10 minutes, work together as a group. One person can share their screen. And then we'll compare and put all of these model classes together. So we've defined the keys, but I want you to define the other properties in the model that's assigned to you. Okay, so room 1 is books, room 2 is cart items, room 3 is orders, room 4 is order details. So we're going to give you 10 minutes to do this. Then we'll take a pause and we'll come back and we'll put all our model classes together. So pause.